And now, part 2. It's been said at least once, in Hawaii, the hands tell the story. Then what's the composition? Welcome back. We don't know the source, however, we're giving it credit. Section 6-6, called Modeling Real-World Data with Sinusoidal Functions. To be clear, sinusoidal is a general term which includes both sine and cosine functions, so any function represented by a sine or cosine wave, or a transformation of those waves, like shifting or reflecting, is considered sinusoidal. Under the subsection Check for Understanding, question number 13. We're assuming the field trip is in the context of this question. The average monthly temperatures for the city of Honolulu are given below. The following table. And the questions: A. Find the amplitude of a sinusoidal function that models the monthly temperatures. B. Find the vertical shift of a sinusoidal function that models the same. C. What is the period of the sinusoidal function? D. Write a function that models the monthly temperatures with the following perimeter: t equals 1 to represent January. E. According to your model, what is the average temperature in August? How does this compare to the actual average? F. The same question for the month of May. Later, we'll do a check-in. Right away, let's consider the givens from the data, such as period. Naturally, it should be 12. We usually denote period with capital T. What else is a given? We should be able to find a maximum and minimum. The max is 81 degrees Fahrenheit. If you like a more moderate temperature for summer, that's pretty much perfect. As it turned out, the min is 73 Fahrenheit. Notice anything else? There's no negative values, which means we'll have to adjust the midline from the standard sine or cosine function, whichever we use. It'll correspond with a vertical shift. Next, we consider equation of the axis. Personally, I prefer equation of the midline. I guess it's a good visual, a midline, and it can be varied. But since we started with equation of the axis, let's stick with that. Recall we have max plus min over 2. 81 plus 73 over 2. What's 150 plus 4 divided by 2? We get 77 as our y value. The midline is going to be way above the standard one. Nice, since we have our max and min, we can find amplitude. Recall the equation for amplitude. Max minus min all over 2. What's 81 minus 73? What's 7 plus 1? We get 8 over 2, which just equals 4. List it, yes. The next characteristic is period. We use the following formula, which will make more sense coming up shortly. we have t equals 2 pi over the absolute value of b, because the period always equals positive. Since our period is 12, we just have to solve for b. See that? Assuming we times each side by b, the next column, we have 2 pi equals 12 times b. Now, just divide each side by 12. The value of b is pi over 6. Now consider f of x and the characteristics that transform a trig function, such as the constants capital A, b, c, and d, read as a times whatever trig function we use, the trig of what's inside the curved brackets, b times x minus c plus d. For example, for a standard sine function, we already know capital A is 1, since the period is 2 pi. Solving for b makes b equal to 1. There's no horizontal shift, so c is 0. Lastly, the axis is 0, so d is 0. The first thing to consider is A equals amplitude, which is a vertical dilation, and all that means is A modifies the vertical distance between the midline of the function and its max and min. Next, the period modifies the graph horizontally, so if you take our first sketch, modify the period, it won't change the amplitude, but will stretch the graph horizontally, so the crests and troughs will appear more rounded compared to a spike. Just imagine a very large period will make the first sketch look more like ridges or smooth dips instead of mountain peaks and gorges. A phase shift is just like it says, a horizontal translation, a transformation of a graph that moves it left or right along the x-axis. In the context of our sine function, it represents how far the graph is shifted horizontally from its standard position. So the shift won't affect the amplitude or period, but will affect specific x values. For example, if our sketch begins at point, say, 1, 1, its midline has also vertically shifted, but let's say we have to adjust our function again, move it to the right 1 unit. Like we said, the shift won't affect the amplitude nor the period, only what was mentioned. As a result, the new starting point is 2, 1. A vertical shift modifies the midline in such a way it won't affect the amplitude nor the period, but this time will affect the specific y values. For example, in our rough sketch, the sine function begins at the same modified point, 1, 1. The max is 2, the min is 0. Y equals 1, the midline. But let's say we have to adjust our m, make a vertical shift. To keep it easy, positive 1. Sketching it. The max 3, min 1. The modified midline is 2. Nice. The new starting point, 1, 2. Recall the perimeter for the graph. Capital C equals t equals 1, which begins at January. So the x value of the starting point of our period should equal 1. We know the values of the constants. A equals 4. We don't know our trig function yet. Just leave as is for now. B equals pi over 6. X is our variable, minus our parameter 1. See how the function works? If we want to shift the graph horizontally to the right, plug in a positive value. Notice it stays negative. That's how it operates. A shift to the left will be positive, while a shift to the right turns out negative. D equals 77. That's how the function looks if we don't apply the constant b. The second column, we apply the b inside the brackets. It looks as if the constant c is pi over 6, but that's not the case. If you want to apply the b, we suggest identify your c and b, then set up the function how it is, the first column, then apply. Sound good? Checking off the questions. A. Find the amplitude. B. Find the vertical shift. C. What is the period? That's done. D. Write a sinusoidal function. We still have to find out which one we'll use with the parameter time t equals 1. Questions D, E, and F, for now we'll say in progress.